So let's talk about your DNA lab, in particular exercise 2 on genetic mutations. So as a quick review first, this lab discusses central dogma. So as a reminder, central dogma states that DNA is transcribed into messenger RNA, and messenger RNA is translated into proteins, and we know that proteins run the body. Also, as a review, let's take a look at the base pairing rules. Always good to review those. Earlier in chapter 13, we talked about DNA replication. So this DNA to DNA. So in that case, the base pairing rules are adenine and thymine pair up and cytosine and guanine pair up. Then later on, we talked about transcription. So again, that's DNA to RNA, actually messenger RNA. And RNA doesn't have thymine, it only has uracil. So those base pairing rules are A and U and C and G. Now in this lab, we're talking about translation. So that's RNA, messenger RNA into amino acids. And to do that, we need a codon chart. So you can't do the lab without printing out a codon chart or using the one in your book. So the codon chart, codons are triplets of messenger RNA. And when we look at this codon chart, the first letter from RNA is along this side, the second letter is along the top, and the third is along the right side. Sometimes you'll see these in a circular format instead. Okay, so for example, let's just say that my triplet is AUG. I go and use the codon chart. So I look the first letter, there's A. Look for the second letter, there's U. So now I have A and U. And then I look for the third letter, G, AUG, and that's going to code for the amino acid methionine, which is also the start codon. If we look at another one, GUU, so remember GUU, we're going to look for G, our first letter, U, our second letter, and then our third letter, U, GUU is going to code for VAL, so valine. So our answer to that one, GUU, codes for valine. So that's how we use the codon chart. Now, if we take a look at the assignment, first you need to translate the following sequence. So we'll do some of that together. So each one of these triplets translates into an amino acid. So use the codon chart. Then it says create one or more point mutations in this sequence, then you translate it, then create a frameshift mutation and you translate it, and then another frameshift mutation, this time by deleting a base. That one you're adding a base, and so on. All right, so let's talk a little bit about different types of mutations. So when it comes to mutations, okay, let's first look at the a point mutation is when we change just one point or one base. So our original DNA has the codon UUA, and that codes for leucine. Let's look at the frame shift after. Let's say that instead of U, we have C. So instead of having UUA and leucine, we now have CUA, and that's also leucine. Let's go back and look at our chart. So there's something called wobble in this chart, meaning that sometimes you can switch one base and still have leucine. For example, leucine is UUA, UUG. Leucine is also CUU, CUC, CUA, and CUG. So in this case, we have what's called a silent mutation, meaning that we get the same amino acid, even though we had a different base substituted in. And this, in this case, now we're substituting a G for a U. So instead of having leucine, we now have valine. And that's called a missense mutation because we could get an entirely different protein or a malfunctioning protein just because one change in a base, right? And then sometimes just that one change, in this case, UUA to be UAA, creates a stop codon. And that would be called a nonsense mutation. So for example, some of these triplets, some of these codons code for stop. That's when the translation would stop. So that's UAA, UAG, and UGA. So those are your different types of mutations, except the frame shift. So a frame shift mutation, and it's easier to explain this way with a sentence. A frame shift mutation happens when a base is inserted or deleted. For example, let's say the correct reading frame is produces the sentence, the cat ate the rat. I chose all 3-letter words. Let's say that I insert an R after the. So then I'm going to change, so it'd be the is fine, but RCA and then it continues all the way down the line into this sentence that doesn't make any sense just because I added an R here. Or I could delete. Let's just say I delete the E. Now I have THC, ATA, see, so these frame shift mutations have a huge ripple effect. All right, let's take a look now at your homework. I did the start of it, so let's see what I did for this. So, okay, your homework says to translate the following sequence. So what I'd like you to do first is to copy down that sequence, either type it or copy it down. And, like AUG, GAG, GUC, UUU, AAG. I copied that down, then use the codon chart. Excuse me. So for example, we already know that AUG codes for methionine. So then GAG, I went and did GAG, and that codes for glucine. And then GUC, so GUC codes for valine, UUU codes for phenylalanine, AAG codes for lysine. So do the whole chart. Then after that, it says to create one or more point mutations in this sequence. So what I chose to do is I started out the same, and then I changed here. My point mutation is I switched an A in for a U. I start out the same, but now I have GAC, and instead of having valine, I have aspartame, ASP. And then the rest of it's the same. So this would be a type of missense mutation. Then it says to do a frame shift mutation. Okay, so in my frame shift mutation, I start out the same, and then I chose to, what did I do here? I added a G in here. See, up here, I added a G in. So I ended up switching the frame, and I actually ended up with a stop codon. So I not only switched the reading frame, but I also created a stop codon. And then I did an insertion, I did a deletion, and I deleted, there's no U in here, so I start out the same, and then instead of having valine, I have alanine, I have ALA, and then it continues down the reading frame. Okay, so thank you and good luck with the assignment.